Alrighty, hello class. We are going to go over perpendicular and angle bisectors from section 6.1. And so our first part says, in your own words, write the meaning of each vocabulary term. So pardon me as I zoom in so you may see. And so I have the definition of equidistant. And equidistant actually sounds very similar to equal distance or equal distant. Okay. Textbook terms, equidistant means is where a point is.
Good afternoon, teachers. This is just a.
Pardon the interruption. So as I was saying, a point is equidistant from two figures when the point is the same distance from each figure. Okay, so that is our definition of equidistant. So now we have four theorems that we're going to go through: perpendicular bisector theorem, the converse of the perpendicular bisector theorem, and other ones with angle bisector theorem and the converse of angle bisector theorems. So our first one is perpendicular bisector theorem. So remember, perpendicular creates a 90-degree angle or a right angle, and bisector means it cuts in half. Okay, so in this part, I have a point that lies on the perpendicular bisector. So this is my point. This is the line that cuts it. Then it is equidistant from the endpoint. So that means AP and PB are congruent to each other. P is like your midpoint. P is midpoint. So CP, this line here, cut AB in half. So that means that these two are congruent to each other. And so that also means that the opposite sides of my right angle are also congruent to each other. That's what CA equals CB. So let's do an example. Alright, let's say I have B, and this is A, C, and D. AB is going to be congruent to CB. So let's say AD is 27, a length of 27. What would CB or CD equal? CD would also equal 27. So if my bases are congruent to each other, that means that the angles opposite of this perpendicular bisector are also congruent too. Now the converse means to switch. So now it's saying that if my sides are given first, so say if I was given 27, 27, that means that the bases AP and PB, they're also congruent. Okay? So if these two, DA and DB are congruent, then AP and PB are congruent to each other. So let's try an example here. So let's say I have S, Q, P, and R. And I want to find the length of PR. So what I'm given is PQ is 5, and PS and SR are 13. But I want to find the length of PR, this entire thing. Well, the first thing I need to know is, what is QR? Well, based on the fact that my opposite sides are congruent, that means that my bases are congruent too. So if PQ is 5, that means QR is also 5. So PR is equal to PQ plus QR, And PQ is 5, QR is 5, so PR must equal 10. So let's flip over to the next page. I have the angle bisector theorem. So if a point lies on the bisector of an angle, then it's equidistant from the two sides of the angle. So if a ray AD, note it is a ray because it has one arrow, and if it bisects or cuts in half this angle, that means these two are congruent to each other. So all I did was take this giant angle and cut it in half. So that means they're still congruent to each other. This also means that if these two are perpendicular, this symbol means perpendicular, and DC and AC are also perpendicular, that means DB is congruent to DC. Okay, so let's do an example. Let's say I have a figure with a giant angle of ABC, and DB is the perpendicular bisector. So let's say that AD is 10. What would DC be? DC would also be 10. Let's say this part of B is 56. And I want to find ABC. Now B is both of these. But if these two are congruent, that means that my angles are also congruent. So this is also 56 degrees. So ABC is this entire angle. So it's 56 plus 56, which means angle ABC is 112 degrees. Now remember, converse means to switch. So now I'm given the sides first. So that's the interior, and it's equidistant from the two sides of the angle. So that means that these angles are congruent. So let's say I had a figure very similar to the first one I drew. No, it is not drawn to scale. So I have J, K, and L, M. KM is the perpendicular bisector. So if JKM is 30 degrees, what is MKL? Also 30 degrees. Let's say JM is 4x and ML is 2x plus 12. How do I find x? Well, if these two are 30 degrees and they're congruent, that means my sides are also congruent. So that means that JM is congruent to ML. So that means 4x equals 2x plus 12. So I'm going to subtract 2x from both sides. 2x equals 12, and I divide by 2, x equals 6. Now what if I wanted to find the measure of JM? All I have to do is plug it back in. JM is 4 times x, but x is 6, so 4 times 6 is 24. So if JM is 24, that also means that ML is also 24. Alrighty, let's look at our extra practices. So we're going to save number 4 for last. So we're going to do the 1, 2, 3, and 5, 6, 7 first. So AB says find the indicated measure and explain your reasoning. When it says explain your reasoning, that means you're using the theorems. That means any of the 4 theorems. So number 1 says find the measure of AB. I'm told that BD and DC are congruent, so that also means that my opposite sides must be congruent. So if AC is 9, then AB must also be 9. And the reasoning for this is I'm given the basis first, so I use perpendicular bisector theorem. That is my reason why. Number 2, ask for EG, and EG is all the way across. I'm given that my opposite sides are congruent, so that also means that these two have to be congruent. So if EH is 3, then HG is also 3. So the entire measure, E through G, is 6. So I have 3 plus 3 equals 6. My reasoning why, I'm giving my opposite sides first, or my angled legs first, so that means I use the converse of, and I'm abbreviating, perpendicular bisector theorem. Number 3 says find the measure of SU. So I have SU and UT. I'm given that SR and RT are congruent. And when those are given, that means my bases also have to be congruent. So if they're congruent, that means they're equal to each other. So 2x plus 2 equals 3x. I'm going to subtract 2x from both sides. I'm left with x equals 2. But it asks for the measure of SU. So I have to plug x back in. So SU is 2x plus 2. When I plug it back in, I have 2 times 2 plus 2, which equals 6. And my reasoning for this, I'm given my angled sides first, so I use the converse. Of perpendicular bisector theorem. So like I said, we're going to save number 4 for last. So let's go on to 5, 6, and 7. So number 5 says find CAB. So I need to find this entire angle measure. But AD is a perpendicular bisector. So if it's a perpendicular bisector, it just cut this angle in half. So that means if BAD is 20 degrees, then CAD must also be 20 degrees. So I need to find the total angle measure of CAB, which means I add them together, so it would be 40 degrees. And for number 5, the reason for this, I'm given my opposite sides are congruent, and so I need to find the angles, so I use the converse of angle bisector theorem. Now, our next one, I have 30 degrees and 30 degrees, and if these two are congruent, that means BD must be congruent to DC, and if BD is 5, that means DC must also be 5. So there's no math required there, and the reason for it is the regular angle bisector theorem. BD, we have our congruent angles. They didn't give us the measures, but we do know they're congruent based on the one congruent symbol that we have. And so that also means that BD must be congruent to DC. So that means I will set these equal to each other. So I have 3x plus 1 equals 5x minus 1. And I'm going to subtract 3x from both sides. So I end up with 1 equals 2x minus 1. And when I add 1 to both sides, I have 2 equals 2x. And when I divide by 2, x equals 1. But it's asking for the measure of BD. So I have to plug 1 back in. So I have 3 times 1, which is 3, plus 1, which equals 4. now we're down for our last equation, our last question. It says find the equation of the perpendicular bisector AB. So this one is an equation. So this is where you're going to need to do 3 steps. And the first step you need to do is find the perpendicular slope. And M stands for slope. And we know slope means we have to rise over run. So let's rise over run with A to B. So I rose 1, 2, 3, 4. And I ran 2. And it is a positive slope. And 4 over 2 reduces down to 2. But I need to find the perpendicular slope. So remember, perpendicular means you take the opposite reciprocal. So that means 2 is the same as 2 over 1. I need to flip it. So 2 over 1 turns into 1/2. And then it was positive, so now it's negative. So negative 1/2 is my new perpendicular slope. The second thing you need to do is find the midpoint. So to find the midpoint, I need to know the midpoint formula. And so I'm going to write the midpoint formula on this side. This is where I have mx, that is x1 plus x2 all over 2. Then I have my is y1 plus y2 all over 2. So that means mx comma my is a coordinate point, which is our midpoint. So we're going to do the same thing with A and B. So A is at point 0, negative 2, and B is at 2, 2. So make sure you label your x's and y's. So let's add. So let's do mx. So x1 is 0 plus x2, which is 2, all over 2. And I'm adding my y's together, so negative 2 plus 2 all over 2. So I end up with 2 over 2, which is 1. Negative 2 plus 2 is 0. And any 0 that's over any number will always be 0. So I have 1, 0 as my midpoint. So I found the midpoint at 0, 1. So now my third step is to find the y-intercept. And the y-intercept is b in your slope formula. So I have y equals mx plus b. I need to find b to have my full equation. I need the full equation. So what I'm going to do is I'm going to take my midpoint and plug it in. So note to plug in midpoint. So I have y equals mx plus b. What is y? Y is 0. So 0, and then my new m, make sure you take the perpendicular slope, is negative 1/2. X is 1 plus b. We need to solve for b. So any number times 1 is itself. So 0 equals negative 1/2 plus b. But I need to get b by itself, so I'm going to add 1/2 to both sides. So b ends up being positive 1/2. Note I add 1/2 to the other side. So I now have my y-intercept. So now I just have to plug them in together. So my new equation is y equals my perpendicular slope, negative 1/2 x, and b, which is a positive 1/2. So that concludes our notes for this chapter. So, or not for this chapter, for this section. You know that my tutorials are Wednesdays and Thursdays after school from 3 to 4 o'clock. If you need to find me before school, please feel free to email me or send me a text through Remind. Also, as far as Thursday goes, let me know if you are in need of retesting, tutorials, extra things of that nature. If you have any questions, please feel free to email me at mariahmartin@misdmail.org. Thank you.